Okay, it's time to start. Good morning, and I'm glad you all made it, despite me saying repeatedly that it was a lecture on Thursday, but that was wrong, and you checked the schedule, which is good. So always look at the schedule and don't listen to me. Anyway, the first lecture is up. You have the smartboard notes, you have the Connect stream, and you have the YouTube renderings. It will be about 6 to 8 hours before the YouTube is actually online, I think. So, but I always start rendering immediately after the lecture, so it will be as soon as possible. We had some nice contributions to the DICE game. I put the implementation that we did in C#. You can find it here, and also 3 other languages that has been added by students in the course. And we have a PHP implementation, a Python implementation, and a Ruby implementation. Feel free to add more if you would like to. Oh, sorry. So there you go. So feel free to add them, and I just take a quick look at them, and they look absolutely fine. So if you would like to look at how this looks in Ruby or Python or PHP, you can take a look at it. It's very, very similar. So feel free to add more implementations as we go along. And that goes also for the workshops, and especially workshop 3. I will be offering you code in C# or Java, and if you would like to work in some other language, you can contribute, and I can use this code for the next iteration of the course. All right. Today we will be talking about domain modeling, and we have quite a lot of materials to get through, because next week you will be having the first workshop, and it's good to get at least some feel for domain modeling before that. And of course you should read up in the book also. But to get this done a little bit quicker than last year maybe, I've prepared some slides, and I'm not really good at making slides, so I use a lot of color instead to confuse you. So yes, domain modeling. A domain model is a visual guide over a specific problem area. As we did in the first lecture, we did a small domain model over this ridiculous DICE game, and we put important concepts like DICE game, DICE, player in it. And we use relations to explain how these are connected to each other. To find problems in the requirements, we found some missing details. So we could improve our requirement. We could add the rule that, okay, it's 2 dices and it's a 6-sided dice. And to find problems and details like this is a good thing, and not assume that, okay, it must be a 6-sided dice, because you never know. And we use the domain model to communicate, both within the development team, to understand the problem area, and between the development team and the customer, and other experts in the area that we are looking into. As software developers, we have a two-folded problem. We first need to be good at computers and programming and development and software and stuff like that, but we also often need to be experts in our customers' problems. So we don't just need to understand computers and computer science, but we also need to understand some other problem area, because we need to help them to get better, to get more competitive, to save money, to change their business. And this is a challenge. And the domain model is a tool to help you understand new problems. If we take a look at what problems we have solved in the education area, mostly before this class, you probably have done in very familiar domains, where you already have a lot of knowledge. For example, the recipe database that you do in the recipe application that you do in the C# course. Well, I guess almost every one of you had read a recipe before that, and you knew what a recipe was, and you knew what ingredients are, and, well, you probably had at least tried to cook something on your own before that. So you had domain knowledge. You had knowledge about food and recipes and stuff like that. Another domain that is often used in education is mathematical domains. I don't know if you did the triangle testing assignment. No one? No, okay. Anyway, we often use mathematics because that's such a well-defined domain. A triangle is a mathematical concept, and it has rules and stuff like that. So we can use it easily. It's well-defined. So, and in education we use that because we don't have time to get into a completely new problem area. But you will probably do that when you graduate and you get your first job. You will probably work in something that you have no idea about right now. Banking, insurance, built-in systems for some specific domain, car braking systems. Well, you don't really know anything about that. And as a software developer, we need to understand other problem areas also to be good at software development. So for this, we use the domain model, and we use it to get an understanding over a problem area and communicate this understanding within our team, with our customers, so that we know that we have understood things correctly, and also to find problems and improvements. And we use the UML class diagram notation for this. I won't be delving into that on this lecture. You can check it in the book. But basically, it's boxes and lines, and you put names in the boxes and names on the lines. It's not more complex than that, actually. There are some more details, but basically that's it. So, when developing, we have the requirements in the unified process. This is called the use case model. Use cases is a form of capturing requirements. There are other forms also, but we have a bunch of requirements. And requirements are good at specifying activities, behaviors, rules, actors. Do you recognize actors? The roles that do something in the system. For example, the administrator can add users to the system or something like that. So we have kind of like a dynamic point of view when we look at requirements. It states what the system should do in different situations, what the system should not do in different situations. In our example, we had this rule that if the sum of the dice are 7, the player wins. This is typically a dynamic behavior. You should display some kind of a win message when this happens. So requirements are good at that. The analysis or domain model is more focused on information. What information is present, what information is needed to fulfill the requirements. So, for example, we need the face value of the dices, and we focus on the relations that we need between concepts to support the requirements. Is this relation needed? And this is a more of a static view. And this is kind of important, that the analysis model supports the requirements. And this is something that you can use in your workshop. Make sure your analysis model supports the requirements, so that the information that is needed to fulfill the requirement is present, and that the relations needed between the concepts is present. So the requirements kind of like delimit the analysis, the domain model. So you only do analysis for the requirements at hand. If you were to do analysis for an open problem, so to speak, it would be very, very large, very complex. So make sure you delimit your analysis model using the requirements. And also use the analysis to refine the requirements. So these are not two exact copies of each other. The requirements are good at dynamic side, analysis or domain model is good at the static side. So they complement each other. They are not supposed to be an exact copy. So use requirements for rules, for example, and you use the analysis model to understand the information and the relations needed. There are some guidelines. I think he has nailed it pretty much in the book, and the metaphor is to think like a map maker. And map makers, they model the real world. They don't try to model something else, but they try to make a map over the real world. And that is exactly what you are doing also in the domain model. Model the real world, not software, for example. Use the existing vocabulary or words present in the domain. Don't invent your own words for things that the user don't know what it is. Don't include too much information. Maps are abstractions. They don't put every little grain of sand or tree in a map, but they have some kind of a focus. Find this level in your domains also. And think about complementing the requirements, as I said before. So maybe some things are better left to the requirements. In our example, I personally would not have added the judge or the rules there, because it only made the model more complex. And rules are better stated in the requirement. And don't add things that doesn't exist. For example, software concepts. As students, as software development students, it's very easy to start thinking about, oh, how are we going to solve this? Well, we need a database, so in goes the database. While this is maybe not at all part of the domain. So try not to think software, try to think the real world. Sometimes it's also, when you face a customer, when you face their problem, they act in multiple domains. So then it's often better to do multiple domain models also, and not mix domains that are actually not that related. So don't try to do everything in one single model. It often becomes more complex than necessary. And map makers do not add things that does not exist. Use experts, ask the users, look in books, find existing models over your domain. Some domains are quite well understood. E-commerce domain, for example. You can use existing models and refine them, remove, add things that are more specific to your case. And also, I think a good idea is to do your domain model and then bring it back to the users or experts in the area and ask them, have we understood this correctly? A good test for your domain models in your workshops is to make your domain model. You have a problem description and some requirements, and you make a domain model, and then you should be able to ask pretty much anyone if they can repeat the problem description by just looking at the domain model. So by looking at the domain model, you should be able to talk about what is this about, and that should be pretty much similar to what you have in your requirements or your problem description. So the first thing we do is find conceptual classes. They are called conceptual classes because they are concepts, important stuff, entities in the problem area. And we did this by checking for nouns in our dice game, pretty much all the nouns we could get a hold of. And that is a good technique. Use noun scanning in your documents, your requirements, to find potential conceptual classes. In the book, he has a category list that you can also look at for common conceptual classes and what to look for. Reuse, of course, as I said, if you can get a hold of a model over the problem area, you should use it and find inspiration in it. And brainstorming. Brainstorming is done by preparing, reading up on the documentation and whatnot. Pour out as many concepts as possible. So you just find as many as you can. And you do not debate during the brainstorming. So you don't start discussing every little single post-it note that you post, so to speak. And after this, we probably have a lot of conceptual classes, or candidates to be conceptual classes at least. Because brainstorming tends to generate a lot of stuff, and checking for nouns tend to generate a lot of stuff. So after this, we need to prune out what are actually the real conceptual classes that we need. Often we have duplicates, things that are actually the same. Sometimes they have different names, but they are the same. So it is not uncommon that a certain type of user names this concept something, and another kind of user names the same concept as something else within the same organization. So you can get ambiguities in your requirements, things that are the same but have different names. And this is something that you need to sort out. And also this improves your requirements, because you can then ask this to your end user, is this the same concept or not? And you can fix your requirements and make them better. And sometimes we have this situation where we have something that we think is a class, or we think that it is an attribute. And I will do a small example. So, for example, you have an item. We have found this in our domain. And by scanning we also have a price concept. So, should price be an attribute in item? or not. This is quite a common situation we have. So we could settle for this instead. So we could say that, well, price, it's just a number. So we remove this concept, remove the price concept, and use it as an attribute instead. We could definitely argue for that. It's just a number. It's nothing important enough, at least, to be a concept in its own. So this is acceptable, but we also could keep the price concept. And use an association instead. And maybe we find out that the price is actually a value and a currency. So price was something a little bit more advanced than just a simple number. So think about, is this really a concept, or is it rather some kind of a primitive? Shouldn't we let out attribute which can be calculated? Yes, that is also a good idea. I think we will come to that as we progress here. So, class vs attribute. We also have possible classes that are so-called report classes. And once again, I will do a small example, and we need to put that one back. We could imagine that we have a student concept. And we have a course concept. And we need to know that, okay, student attends multiple courses. Could be quite a common situation. You attend a lot of courses. And the students can also get a, let's just call it a course report. So in our requirements, we have something saying that the student can get a printout of all the courses that he has attended. So, course report concept then. And maybe we could just say print. However, this concept is just a report over information that is already present in the model. You can get the courses by just using this relationship between student and course. And while the course report is a physical thing in reality, it is something you get, it is just a report over the information. So then you need to ask yourself, does this add important value to my domain model, or is it just more noise in the domain model? So just because you can do something in the system does not mean that you automatically need to put it in your domain model. You need to exert your judgment and think like a map maker. Is it too much detail? How many other concepts do we have? How many other relations do we have? If it just adds clutter and no real new information, well, then maybe we should not add it. It is likely that you, in your requirements, you have the student actor. And you have your print course report use case. So you don't need to duplicate the requirements, really. And if you have this kind of like obvious case that, okay, we can look at the requirements and see what the students can do, well, then maybe it is not adding that much to the understanding of this problem. So think about report clauses. Do you recognize this notation? No? Yes? No? It is also part of the UML, but he uses it in the book, and you can look it up there. This basically means that we have an actor, some role in the system that is called a student, and the student can do different things, and this thing is print course report in this case. So that was report clauses. Description clauses is another common case that we should take a little bit more look at. So imagine we have a let's just do it like that. Something more in my example. Yeah. So we have found this concept car, and we think that cars have a color, they have a registration number, they have a description, and they also have a price. Now we used price as an attribute for some reason. But anyway, this seems to be fine, but thinking a little bit more about it, we can probably see that all the cars with the same model share the same description and the same price. So maybe we have a new concept here, because this will add a lot of redundant information. So maybe it is like this instead. We have the car, that is the individual car. It has the color, and it has the registration number. But then instead we have the car model. With the description and the price. And this means that we can have a lot of different cars. We can have a red car, And we can have a blue car with different registration numbers, but they can be of the same car model and share the description and the price. So you could think about this as, at the car dealer, you can take a look at cars, and you see the actual cars, their color and their registration number. But you can also take a little paper that describes the model, that describes the price and whatnot. So instead of writing this information in each and every car, on each and every car, they have a separate concept for that. And often, actually, when we think about things, we actually think more about the description of things and not the actual physical item. So this is also something that you need to think about. Is this more of information that is shared among a lot of objects in this domain? Or is it something that is unique to every object? It could be that, well, every car actually has a unique description. Maybe it gets some basic information from the model, but it also can add or remove the description items and have an individual description for each and every car. I could imagine that this would be important in used cars, for example, as they probably have some wear and tear that could be important to convey to a customer. So things are not always good or bad. They are on a scale. Bad, better, good enough. And this also makes domain modeling hard, because you are used to hitting a compiler button and see that, oh, it does not compile, so I made an error. And this you need to think more and actually try to understand more. So the next thing, actors. Yeah, this is called description classes, as we just did, and we will talk a little bit about actors. Actors in the systems are the people that can do things. For example, the player. Student, maybe, we had here. Student could print the report, course report. Administrator is a common actor. Well, the people, the roles that people play in a system that actually want to do stuff in the system. Sometimes these are good conceptual classes. Sometimes we need to store some kind of information. We need to know that the student has attended a couple of courses because he's supposed to be able to print his student course report. In other cases, the actors are just the people that can do things. And just because you can do things does not mean that they are supposed to be included in the domain model. So don't automatically just put all the actors you can find in the domain model. Think about, do we need to store some kind of information to, to support the requirements? Do we need to know something about this actor over time, what he has done? This is something that you will need to think about in the workshop, because there you have a lot of actors. You have members, I think, and you have secretary and cashier and stuff like that. Should they all be included? Should they not all be included? You need to think about it. And also, don't mix domains. If you find, okay, we have this bunch of concepts that are really related to each other, and maybe you have some other grouping that are more related, and they don't seem to connect really, then you probably have different domains. And don't try to mix domains in the same model. It is not that easy to understand often. And sometimes this other domain is just something that is necessary to get the system to work. It's actually more of a software kind of thing, but it's disguising as being part of the domain. So look out for that. Get a question here. So in a domain model, we should show and present the relationships as well as the behavior using different UML diagrams. No. In the domain model, you should focus on the conceptual classes and the relations between them. And it's more of a static view, and not the dynamic side is more requirements. So, for example, in the dice game, we had this rule, and we could not really make out the rule by looking at the domain model. Rules are better described in requirements. In the design model, however, we modeled actually the dynamic side and the static side. But domain modeling is more of a static side. So you need to think about adding this to the domain model. Is it better expressed in the requirements, or should we include it in the domain model? Domain models have a tendency to be quite big, complex, and this does not really help understanding. So the goal is to find a good balance. What is actually important? What is hard to understand in this domain? That is what we should show. So we have a lot of conceptual classes. Often when doing this and doing the pruning, you kind of like find the associations also. But a little bit more specific, an association is a named relation between two classes that is meaningful and important. So it supports the requirement. Often it is something that is needed to be remembered, some kind of a history. We need to know the courses a student has attended to support the requirement of printing a course report, and probably a lot of other requirements also. Scanning for verbs can be a good thing. Nouns, conceptual clauses, verbs can be good candidates, at least, for association. And we can also use the common association list as presented in the book. Some guidelines: use good names. That is maybe the most important thing about the associations. You should use a good name, just not can do, has, contains. It does not really tell you. So in the dice game, we showed that the player actually rolls the dice and not just uses or something that actually does not tell you anything. We can add multiplicity when we need to. In many cases, it is quite easy to understand the multiplicity. That is, how many of something is related to how many of another thing. It is natural and not really a problem. But in some cases, we add it to add details. In our dice game, we added that, okay, the dice game actually contains 2 dices. Yeah, I think we will do a small example. So we have a person concept and we have a car concept. And a bad name would be has. A person has many cars. So we should instead look for what is it actually that we are saying. So maybe we're saying owns instead. Because this relation means that, okay, the person actually legally owns the car. Has a car is, well, does he own it, or does he drive it, or has he stolen it? And we can also add multiple associations if we need to. So if we need to have some other requirements that when we need to know who has actually driven this car, maybe at an accident, who was the driver? Well, we can have different drivers and owners. So then we add another association. And I think that, well, a person can own multiple cars, so then we set a little star, and the car can be owned by multiple people, over time at least. And a person can drive multiple cars over time, and the car can be driven by multiple people. So maybe in this case it is not that interesting to add these multiplicities, because in real life, many-to-many is quite common, especially when thinking about, okay, do we need to have some kind of a history about this? But as I said in our dice game, more specific number of dices was good information to show, and it was also something that we asked, and it was missing in the requirements. So maybe in our system, it is not that a person cannot not have a car. So maybe we have this situation instead when we really think about it. In our insurance system, or what this is, it does not make sense to have people in it that do not own a car, because we're a car insurance company. So we don't deal with people that own boats or does not own a car. And at the same time, we cannot have cars that do not have owners. So a car needs to have at least one owner. We cannot have loose cars. That would be bad for us. And if you have not insured your car in Sweden, you will get a letter with a really, really high amount of money to pay compared to getting a car insurance. Because there is a law in Sweden that says that the car owner needs to make sure that his car is insured. And this is actually interpreted so that the car owner is the one that needs the insurance. So I cannot insure another person's car. Anyway, details like this can be good to display, but as you see, it also adds some clutter. So think about it. Just don't automatically add many-to-many everywhere. If it's interesting, add it. If it's not that interesting, or obviously you get it, you don't need to add multiplicity. You should always add good names. And sometimes it actually has or contains or something like that. So, well, you can use it, but try to find a better name, what it actually means. Yeah, derived associations. yeah, we could have this teacher. Time to wake up. So we have teachers that are employed at universities, and this is handled using a contract that has a salary and a time and stuff like that. So in this case, we can see that, okay, maybe teacher works at the university, but it's not really that obvious because you need to go through a chain of associations to find this out. So if it's really, really important that the one looking at the domain model can understand that, okay, what we want to show is that teachers works at the university. We can add this association also. But just as with the report classes, this is just kind of like something that we can see by looking more closely at the other associations. So by using this contract that is necessary in the domain, we want to show that the teacher works at the university. But this becomes maybe too complex to really see that immediately. So we can add this, and then we add a little slash before it to show that, okay, this link, maybe it does not really exist, but it's good for understanding, and it can be derived by looking at something else. And actually in this particular situation, it is better to use something called an association clause. Then we kind of have the best of both worlds, because adding another link, another association adds complexity, adds cluttering, and in a big domain you get a lot of associations, so you always need to be careful about readability and understandability. Teacher, university, so we can have this and add an association clause. So this is a clause that describes the association. In this case, it would probably be a salary and some time, and maybe the persons that have signed it from the university or something like that. Yeah, we have already talked about multiple associations. That is, you can add multiple associations, as we saw in the car example there. We have composition and aggregation. I will not talk so much about them because you should not use that in your domain models. Both composition and aggregation are special kinds of associations where you want to display whole and part really, really obviously. However, if you search for UML diagrams, you often find these diamonds because they were very popular for a while. So I will show them. Hand, finger, you have this black or filled in diamond shape, but it's just an association. It's the line, and then it's the diamond. And this is to display that, well, a hand is composed of 5 fingers. if we remove the hand, we also remove the fingers. And the aggregation looks like this. It's a diamond that is not filled in. And this also means that, well, a car can have 3 or 4 wheels, but it can also, the wheels can be removed also and live on their own, so to speak. But both of them can be done by using the common association, especially in the domain model. So if you're not exactly precisely sure about what you are doing here, you should use the common association. And this means that you should probably use the common association every time. It's like in Swedish, if you cannot separate de and dem, use dom. That's always correct. So go for this. But don't be alarmed if you see UML diagrams with these diamonds. And lastly, the most fun kind of association to think about is reflexive associations. That is, associations to concepts of the same type. This is my favorite example. So we have a person and 2 persons make multiple other persons. And we call these parents and children. And as you see, this is quite powerful. Reflexive associations are powerful and complex, but they can exist. It's sort of like a file system. It's kind of like recursive. A file can be a folder that contains other files and other folders. And we see something else here. We have the name. You have seen this before, but here we have role. And this is important, especially in reflexive associations, because you need to know what kind of role one object can play for the other. So we can have person objects that are parents and at the same time be children. And it is important to know this information. This becomes even more important in the design later on, because then we do not use the association names anymore, but focus on roles. But we will talk more about that later. In the domain model, we primarily use the names of the association. But you will remember this for the rest of your lives now. So I think it's time for a break. Any questions? No? You will have some homework during the break also. Yeah. We will take a little bit of a longer break, and I will do the last stuff of the domain modeling during when we start the lesson again. But I have a small problem for you. So stretch your legs for like 5 minutes, get some coffee, gather around in groups, and make a domain model over this problem. I have 15 printouts for you here, and I will also post a link in the chat on Adobe Connect. So let's find the link. Here we do go. Yeah, let's take 20 minutes. So half 9:30. You find the problem description on this page. It's I have a Swedish one and an English one. So we will gather again at in 20 minutes, so 9:30.